Okay, and a good morning to everyone as we start up the morning. And Jonathan, we were listening to Rod Stewart, and what was the cut we were listening to?
Stay with me.
Stay with me, indeed. So, first, let me do some summary here. We've been going through some material the first couple days of the semester, and this is the first day that we are going to be broadcasting with 3C Media Solutions through Palomar. And so, in a sense, this is the first day of the semester for people watching our broadcast on the 3C Media Solutions network. So that means we're going out to all the community colleges in the state. And this is a Math 20 course. Okay, and Jonathan, you want to bring that in just a little bit tighter on the cut. We're dealing with Math 20, which is a pre-algebra. Looks good. The pre-algebra is a follow-up to what we did last semester. If you happen to be watching us, we did Math 10, which was an intro to math. Now we're into a pre-algebra. And this is part of what is being a two-semester sequence. This is a bridge program through the EOP&S program. And we are a group that have been meeting together for 2 semesters. This is our second semester together. And there's some new things that we're trying. We're doing a book, Pre-Algebra by Carson, and it ties together very nicely with what we were doing in our Math 10. And we are going to be doing something new that I haven't tried before, and as I explained, the effort to do this is with the idea that students have had better success rates, so we're trying it. It's a computerized homework system. And the first couple days, we have been challenged. I've been challenged with the computer in here, and with Larita's help, we were able to go ahead and I think get everybody registered on Course Compass. And some of you have been working problems there, and I don't have answers to all your questions that you've been asking, but we'll try to deal with that as we go along. One question was asked today I'd like to come back and look at. Now, the way I had things set up today was the deadline, I think, for section 1-2 was today, and I'm going to have to modify that because by 10 a.m. you were supposed to be done, and we didn't finish all the discussions, so I need to go back and make arrangements for that so that you can continue working on the material. The intent in a pre-algebra, for the way we do it, is to go ahead and assume that you have a pretty darn good background now in what we did in Math 10, the arithmetic portion. So a lot of what we are looking at for this group is a lot of review. Certainly been the case in the first 2 sections. There are a few places where there's some wrinkles that I think are tending to cause some confusion. But that sounds like a good old-fashioned one. Okay, search and destroy. As we go ahead and we look at estimation, that's a new idea for us. Okay, and certainly the idea of an equation is something new for us. So we're going to bring those in, and as we look at section 2 and 3 of the text, you're going to find that the material is a mixture of most old familiar and some new. So for those of you who, as I say, are just joining us this morning on 3C Media Solutions, and you want to know what materials we happen to be using, this is it. It's 3rd edition, Pre-Algebra by Tom Carson. Okay? And so this is the text we're using. Let's cut to that again, Jonathan, if we could, please. 3rd edition, Pre-Algebra with Tom Carson. And the intent, as we come off there, is to cover all of the chapters. Now, some of the things we started on were the usual things such as the word for addition being sum. And if we look at that first chapter that we've talked about, we've done some problems there, the focus was on whole numbers. And the whole number idea is something that you think of counting numbers and put a 0 with it, and you have the whole numbers. And probably the thing that would be new here for many of you, if you're watching, is some of the language. So we talked about expanded notation, and we talked about the word form, which we call verbal notation. So a little bit of difference in the language. And we talked about place value. The one thing that we introduced that was new, that you haven't seen in a Math 10, is this one, okay, coming to the book now. And that was the idea of an inequality. This is on page 5. And this is where we had the greater than, the less than. And what I commented to some of you, and we did this in lecture, mentioned if you think of this like the directional signals in a car, this says to the right, this is to the left. Well, we think of two numbers, 12 and 9, and we think of them being on a number line. And when we have them on a number line, we would say 9 is to the left of 12. So you would write 9 is less than 12, and you can see that at the bottom of the screen. Or there's a reversible form of that, and you say, well, 12 is to the right of 9. So if you think of greater than to the right of, less than to the left of, and listen to the sound of the L and the R, think of your directional signals in a car, this shouldn't be a problem for you. That's my hope. One of the things that is a slightly different language again, as we look at the bottom of this page on number 5, we talk about number lines as we go to the document cam, and we talk about line graphs and such. Well, this is just your good old-fashioned number line we've done before, and we've just included the whole numbers there. You realize, of course, that there are values in between for fractions and decimals. And then when we talked about graphing in our Math 10, you note that we can go to the left and have a -1, -2, and so on. And just a comment, when we extend the wholes to the negatives, we call it integers. And that's the big difference, perhaps, at the beginning, focusing on the negative numbers right away. This was an idea that's a little bit different for you, and it had to do with estimation, and it has to do with a question that Bill Morrow and Ephraim asked me about. And I guess, James, you may have been involved in this discussion also, so we'll talk about it. But as we look at page 7, we talk about round numbers. And the idea here is to take a number and write it with one non-zero digit. So as we come off there, I'm going to give you the problem that Bolmaro and Ephraim shared with me. And I can't get it easily all on one shot as much as I'd like and have it as readable, but that's the best I can do. So as we cut to the document cam, notice it was in horizontal notation, and I've shared with you before that this is typical of pre-algebra and algebra. And the numbers, fortunately, go from large to small, correct? So down here, your smallest number is 507. And so this idea that was new in this first section was to take this number and write it with one non-zero digit. So that meant it had to be 500. So you were rounding off to the hundreds place. Now, once you do that, if you're going to estimate solutions, the expectation is that you will take each of these three numbers and round them off so that they are at the hundreds place. And this is where you have to be remembering some things. So this is the hundreds place here. The next digit is a 7. So that means you take the 0, put it to 1, and you get 2100. Okay? Now, here's my hundreds place again. Next digit is again a 0. So that means you're going to leave this at 42,200. Here again is your hundreds place, but now the next digit is what? 7, so that forces the 5 to a 6, and you have 135,600. Now, to estimate your answer, and there's two things that you're going to be asked to do in these problems. One is do the estimation and get your answer from the estimates. So all I did was line these numbers up. And I get 180,400. Now, once you've done that, you're expected to do this. And I apologize, I was just sketching something out here. I wasn't trying to make it so that it was going to be presentable, and that was an afterthought. But I line up the numbers, and I find the actual answer. And notice, 180355. You compare these two answers, 180,400, 180,355. They are very close. In fact, this one will round off to the other one. Now, why would we do estimates first? Well, the idea is to try to, in doing estimates, avoid some of the numbers that we would be adding together typically. So this is an advantage. Now, we have a question. Natalie.
Okay, so yesterday when I was doing this on the computer, I kept getting confused because I don't really get what you mean by the one non-zero digit, because when I was coming out with 13,000, I thought it had to be like 10,000 because then there's two non-zero digits. You see what I mean?
If you had 13,000 was your smallest number, then you would round it off to 10,000.
No, but like if it was 13,285.
No, I understand that. But the question is, what was your smaller number? What Natalie's asking is, if you're rounding off to one non-zero digit, how do you get two non-zero digits?
Right.
Okay, is that the question? Okay, let's look at the problem again. I'll try to bring this down just tighter to this portion. This is your smaller number. That I rounded off to one non-zero digit. Now, these are going to have more than one non-zero digit, but I round them off consistent. This went to the hundreds place, so that has to go to the hundreds place. That has to go to the hundreds place, and so here I have two non-zero, three non-zero. That's the game we're playing.
Okay.
Does that answer the question?
Yeah, as long as it's like stays the same place value.
Yes. After you do the smallest first, then everything else is consistent with that place value. That was the confusing part, I think. Now, Bomaro and Ephraim had a chance to feed back to me in this. James, are you comfortable with that answer at this point? Yeah, it feels weird in a way, but does it make sense now? And then the question is, ideally, you should be able to put the numbers in the computer, and it should accept them.
Yeah, it's not. That's what it was doing. It wasn't accepting it. Like, we'll start from, we'll go from left to right. Start with the smallest one.
Yeah.
And then work quick to the highest, and then add it up at the end.
And get your estimate.
Get your estimate, and it wasn't.
Okay, but wait a minute. If you enter, you have two things you're supposed to do. Your estimate and the exact answer. So we have two numbers here now. Let's come back. Here was my estimate. Then I'll just slide over. Here was the correct one. Now, what is the computer asking for you? The correct answer or the estimate?
Both.
If it's asking for both, estimation first, and then you put that in, and you enter, and then it asks you for the actual, and you're saying it bounced you out as being wrong when you tried that? I'm getting some yeses and some nos. Okay, hold on. Let me, Jessica first.
If you're off by a digit, like you misplaced stuff on the computer, it'll tell you it's wrong. So I did that a couple times.
When you say misplaced a digit,
Like if I put, like, say that the zero is supposed to go, I put a zero before, and then the one, like I confused my numbers when I actually put them into the computer.
You reverse the digits. You have to be careful of what you enter. Okay, Sandra?
After like 3 attempts, it'll tell you your right answer and what you did.
Okay, yes. No, I understand that. After 3 attempts, it'll give you a correction. But if you're doing what Jessica said, you know the answer, you know the procedure, you thought you were putting it in, and you reversed a digit, or your fingernail hit another key that it wasn't supposed to, something like that, you don't realize what you've done wrong, and so that could be a problem. Larita.
I was helping Nancy a few times that we were putting in the exact estimate, and it was saying, it would prompt it like it's wrong and give the correct answer, which was the actual answer that she had put in a few times.
Okay. Okay. What I'm hearing, and I'll just take it under advisement, I know that from what Sarah was talking with Dr. Jarrett last night on the phone, and they're using it also. And there were a few glitches yesterday with the system, and I think it may be an overload. What we do, we take your comments, such as the one that you're sharing, and then that's given back to the company, and they immediately address it and try to take care of it. The person who is responsible for our particular area is going to be coming tomorrow, and we'll have a chance to talk with him a little bit. I understand what you're saying. The key here is patience. Let me know, and maybe try a different problem, a similar problem, and see if it does the same thing again.
Yeah.
Okay, before I can't, Isaac. I do. I told you yesterday or the day before. Sometime, the question that's being asked, can I just assign pages from the book? I do. I have on the web page for the course the page numbers and the problems. Those are the same ones that are being assigned using the computerized base. So yes, you can do that. And what you should be doing is writing down your solutions. And if you believe you're right, then you come back and you say, here's what I did. I tried putting it in and there was a problem. From what I'm gathering, the difficulties are very minimal. And if you are patient for just a little while, I think you're going to find yourself really benefiting from the additional practice you can do and the opportunity to get those 100% grades in homework. Remember the caveat here. If you do decide you're not going to use the computerized based homework, I will take your grade for homework from the 3 practice tests you do. There's nothing to buffer that. So if you get a 70% in that and you had 100% in your homework in the computer, that's going to raise it up considerably. But if you don't have the computer, you live with the 70%. I'll talk about it more later. You make some decisions on that. Dion.
Oh, yeah, just a couple things real fast. I just wanted, I had, like how you said, to try another problem.
Yes, do another problem.
But I was doing that too. Like, I would just put in the incorrect answer and then enter, and then I would go to a similar question, right? And I ended up doing that one like 3 or 4 times, coming up with the same answer and putting it in, and it wasn't coming
And it still wasn't coming through. Okay.
I was also writing it down and keeping down my answers.
Okay, good. And we'll talk about that and see, make sure there was no problem there. And then, I guess that brings up a question in terms of, 1, dropping by during office hours, which are 1:30 to 2:30, dropping by during the tutorials, which are 2:30 to about 3:30 or 4. And I don't know at this point what hours you're going to try to have available. The same hours. And the idea is start asking and get some help. This is a new experience for us, and let's not panic in day 3. Okay, and as I say, I don't want to belabor that because I need to go on to other material and talk about it. Make sure you're writing out your solutions like Dion said. Write out your solutions on paper. Then talk about it and see if you're having any problem. If it's just entering it into the computer right now, patience with that. I think it's going to take care of itself. Okay?
Yeah. I just got a quick,
Another question. Okay.
Remember you told yesterday in the class that if we needed in the next day for the other homework, that you would do so?
I'm going to, and I didn't get that done this morning. I ran out of time at 4 a.m., and so I will have to do that. I will extend it. I will extend it. Yes, I will extend it so you can come back. And my apologies to you in that. I was sitting there, and I had 16 more emails to go in 5 minutes, and I just didn't think to go back and change that due date. And I thought of that on my way in, and then, of course, it was this computer has not worked for me, so I was sort of stuck. But let's keep going. Another new idea we had. I'm trying to cover new ideas that we covered in the first couple days for both people watching from Palomar on our presentation there and for you. We talked about the median of a set of numbers. Okay? And so the idea is that we had a set of numbers that we usually collect. We call it data. We get them from samples we take. We ask questions. We get data. And so as an example, if I looked at, and I'm going to go to the board in this, but let's say I looked at the number of problems out of 10, and I just looked at 5 grades I saw, maybe a 7, an 8, a 3, somebody had trouble, somebody else did fair there, and then another person really aced it. Nobody got 10 out of 10 the first time through. Now, they're mixed up, right? So I have to rearrange them. And the usual thing is from either high to low or low to high. That does not matter. So we call this a sort, and so I have a 3, a 5, a 7, an 8, and a 9. So I've sorted the numbers. The number that's in the middle is called the median. And we refer to that, interestingly, as an average, like the average price of a house in California or any other place. So the phrase here is median. And the obvious question is, what happens if I don't have an odd amount of data? So let's say I have only 4 numbers now. Then these two share the middle, and I just average those two. I could add them, 5 and 7. By 2, that's 6. That's called the average of it. So if I have an even amount, I find the middle numbers and average them. Now, I went a step beyond the book, as I tend to do. And I talked about the mean, M-E-A-N. And the mean was to add all those numbers up, like you do your test scores, and you find what we call the average test grade. That's called a mean. So in this case, we would have 8, 15, 23, 32. So I'd have 32 divided by how many I have, which is 5, and that will be 6.4. Notice the mean and the median are not the same in this case. Now, Bomaro brought up that there's a mode, and indeed there is. A mode is the data point with the greatest frequency. So, in this case, there is no mode. If I'd had, say, a 9 and a 9 here, then the 9 would have been the mode. Again, the data point that has the greatest frequency will be called the mode. And ideally, the mode, the median, and the mean, we would like to be the same number in a distribution. So for the moment, that was the new material there. Now, yesterday, we brought up some notation, and I need to talk about that. And this was notation about saying we have a set of real numbers. We've talked about the real numbers before, and remember, it was all the fractions, all the decimals, all the integers we could have. And we then did something I had done in Math 10 before. We said, let's let letters of the alphabet represent numbers. So we said, let's assume that A and B are real numbers. They just represent some arbitrary number. And we said that if you add these two together, it doesn't matter which way you do it. So we wrote A plus B was equal to B plus A. And we called that what property? Commutative. The commutative property. So commutative. Okay. And that was a very important realization, that it doesn't matter which way we add numbers. Reverse them, you get the same answer. Okay. We just pronounce it commutative, like you're going to commute between here and San Francisco, or here in Oakland, or here in Fresno. Now, we also have it for what? Multiplication, that AB, and we don't put an X between it. Now, you may find sometimes a dot be between the two, meaning multiply. But AB is equal to BA. And that is the commutativity for multiplication. And that's the new material in Section 3. We also had a problem called the associative property. And that's where we said, if I have 3 numbers now, so A, B, and C, it doesn't matter how I group them. So I can say A plus B first, then add C. Or I can say add B and C first, and then take that sum, again, meaning add. So scoot over just a little bit. There we go. Now, enough to where I can still see real. There we go. Looks good. And this is called the associative property of addition. Well, if you think about multiplication, remember when we write letters together this way, it means multiply. That means multiply A, B, and C together. So again, we're arguing it doesn't matter what you multiply first. And we argued this all the time we were in 10. Didn't matter. You can do it that way, or you can multiply the B and C together first, and then multiply by A. Mix and match, if you will. This is the associative property. for both addition and multiplication. Now, there are a couple more properties while we're at it. Let's just summarize these because these are part of Section 3. And I've told you there are how many of these? 11 of them. Okay. Now, there are two properties that are not talked about typically in most intros. They are called the closure property. So let me write up here closure. And it just says that the sum of two numbers is a real number. So you add two things together in reals, you'll get a real. Think for a moment. If I start with just the odds, 1 and 3, add them together, and what do you get? An even that's not part of it. No closure. A plus B and A times B are real numbers. So if somebody says get real, you have a new meaning for it. Okay, so you have the idea of closure. Now, how many properties do I have so far? Be careful. These are doubled. So you have 2 here. You have 2 here. There's 4. And then these 2 make 6. So you're up to 6. Now, when you add 0 to anything, it doesn't change it, correct? So the idea is if I take and add 0, it doesn't change it. I still get A. And if I multiply something by 1, I still get what? The same number. This is called the identity property. Identity. And this is in Section 3 also. So we have identity. Otherwise, you don't change something. You retain your identity. You're still the same thing, same person. How many are we up to now?
8.
Doubled them. Got to keep thinking in terms of doubles. So I think we're up to 8, is that right? Well, got another. It's doubled. 1 for addition, 1 for multiplication. Both of these are commutative. Up here is closure, addition, and multiplication. Both of them real. So that's 2 there, 2 here, 2 here, 2 here. They're all real. Agreed. Real is the set of numbers. Keep real. Get real. It's the set of numbers we started with. We always get real. Okay, continuing. There's a new one for you. Robert. No. If I take 2 plus 0, what do you get? 2. So if I start with 2 and add 0, I get 2. I start with A and add 0, I get A. You don't need B, just the A. Okay, keep going. Let's put addition and multiplication together. I'm going to do this. This is a single, James. This is by itself. It's just going to be the distributive property. A times B plus C. We're going to distribute the A across the parentheses. So A times B and A times C. This is my July 4th one. The rockets and the red glare. Okay, so that's going to be the same as A times B plus A times C. It might help to give you an example there. This is the one that's not so obvious, I suspect. This is going to be the most critical of the properties for the algebra class, because remember how we factored numbers into primes? We did it a lot. In algebra, we're going to factor expressions into products, and we're going to use this property. But let me give you an illustration of what's involved here. So, Jonathan, now, just, let's see, where do I want to come? Left justify here. That'll give me enough room here. There we go. So let's say I have 2 times 3 plus 5. Now, that is doing a multiplication because the 2 is in front of the parentheses. That's understood. Now, we're saying that that is the same, and I'm going to put in parentheses because the dot's going to look like 2.3, looks like 2.3. And if I write an x, then we're using x to represent a number, so that doesn't work well. So I'm just going to write this with parentheses, meaning 2 times 3, which is 6, 2 times 5, which is 10, we get 16. Well, if I think of what I'm getting here, this is 8, and I have a 2 out here, that would give me 16. So I can do the parentheses first and then multiply, or I can use the distributive property and rewrite it as the sum of 2 products, product, and then add. With numbers, it probably seems like a lot to do about nothing. But when we get to algebra, and we get to expressions with letters, it is important. Now, I'm just going to give you, when we get to algebra, it becomes very important. When you're working with numbers, it doesn't seem like a big deal. Let me just illustrate something here algebraically. I'm going to give you an expression. So an example. Let's say I have 3x plus 3y. Now, by the distributive property, I can rewrite that this way. Agreed? Because that's what the distributive property says. We say we have factored the expression, so it can be written as a product. One more time. Using familiar language, I factored an expression into a product. This is a product because I'm multiplying. This was the sum of 2 terms. Language getting really important here. So here I had a sum of 2 terms. Here I have a product involving 2 factors. What we multiply together were called factors. So when you told me that 15 could be written as 3 times 5, the 3 and the 5 were the factors, the 15 was the product. You factored into a product of primes. Each factor a prime. That should be a familiar concept to you. And what I did here was to take an expression, not an equation, because there's no equal sign. An expression that involved 2 terms I was adding and wrote it as a product. I'm not seeing a comfort level that I like in your eyes right at the moment, but that's where we're headed, and that's why that's important. Okay. Coming back over here.
We have 8 out of the 11 still, correct? 9 out of the 11.
Okay. We're missing 2. You're correct. Before I do that, Michael.
So that expression is the product.
Okay, Jonathan, we're back in the right side again where we were. This expression, and indeed it is an expression, is a product because the 3 in front of the parentheses says you're multiplying. Now, it happens that there's a sum inside the parentheses, but that nonetheless is a product, as I've written it.
Are you going to multiply that?
I could multiply, and of course I get right back where I was. There are times when I want to leave it factored. See, when we factored composite numbers into product of primes, we wanted them left that way so we could find common denominators. Step further. I'm not disappearing totally, just getting chalk. I hope, Jonathan, you stayed where we were. Yes. That's an equation, whereas this was an expression. It's an equation because of what? The equal sign. Now, we talked about finding the solution, and this is part of what's in 1.2 and 1.3. Finding the solution, what's one approach? Eyeball it. Give it the evil eye. The 3 works. You've got a solution. You looked, you saw, you're done. Okay? Things don't always work this easy. I promise you. They don't always work this easy. Now, approach that I talked about yesterday or the day before, I've lost track of the 2 days, which seem like a month at this point to me. I could subtract 5 from both sides and get x equals 3. Now, that's called a related equation. Otherwise, I subtract the same thing from both sides. It should still remain equal. So I subtract 5 from both sides, and I get x equals 3. I've simplified, and I now have a solution. Okay? The idea of taking an equation and ultimately getting 0 on one side is going to be very important to us. So I could have said, this is bad. Okay, I did not do this problem well. I could have said x minus 3 equals 0. Subtract 8 from both sides. 5 minus 8 is a negative 3. So we would have had x minus 3 is equal to 0, and that's easy to see. So ultimately, and that part may not set well with you, and look at the TV if I'm blocking your view. Camera. Now, if I have this here, and I can get 0 on one side, seeing the solution is pretty easy, and that's going to be our technique, to try to get 0 on one side. So if this turns out to be something I can write as a product of things like this, getting the solution's easy. That in a thumbnail is Math 20, Math 70, Math 90, 121, 122, 171, right up through the calculus sequence. That process is what we do. Get 0 on one side and write the left side as a product of factors, each one like this expression. That's where we're headed. That is mathematics, all the way up through calculus. Okay? I hate to do that to you day 3. But why not? Okay, going back. Now, Emily has told me that I'm missing 2. You're right. I'll give them to you in this way. I'm not going to write them down yet because it's not appropriate. We're still with whole numbers and integers. For every whole number for the moment, like a 4. Now, I just realized somebody's not here that I was going to reference. But nonetheless, maybe, Isaac, you said this. No, you haven't even heard it, and you're just claiming already. For every number like 4, there is something we call the reciprocal. I was thinking it was Richie, but he's not here to hassle. For every number like 4, there's a reciprocal called 1/4. Now, what's 4 times 1/4? 1, which is the identity. So for every number A, there is a number called 1 over A, so that when I multiply them, I get 1. No, if I take A times 1 over A, I'll get 1. 4 times 1 over 4 is 1. That's called the reciprocal property, or the inverse of multiplication. Now, what about the number 4? For every number 4, there is a negative 4, so that when I add 4 and negative 4, I will get 0. That's called the inverse for addition. Now, it's inappropriate to talk about those until we get to integers and rational numbers. Both of them are inverses. One for addition, one for multiplication. And those are your 11. And by the way, listening to the news this morning on NPR, you've got to really like where you're living today. They were talking about northern Minnesota and North Dakota. The temperature, minus 40. The high for the day, minus 20. Minus 20. Okay? And what is it outside? Sunny? Maybe 50s? I think we're supposed to be in the mid-50s today. 2 days ago, 85 in Santa Rosa. It's nice being in California until we run out of water. Okay. We have covered some language. Mind you that when you add, you get a sum. When you subtract, the answer is called a difference. And the one place where I'm going to disagree with the presentation in the text is with subtraction. When I subtract, what method will I use? The Austrian method. No, you're not supposed to say, oh darn. And I made the language more acceptable. The Austrian method, just a reminder. How did we subtract? Let's see if I have any room left up here. I don't. We would have added, but if we're going to go over to the side, so might as well run over there. So when I do subtraction, I'm going to think in terms of doing addition. And I need to share that with the people who haven't seen it before, who are watching for the first time today. But the idea of subtracting in your text is represented somewhat as a takeaway. That bugs me, because I don't think it's in our best interest. So if I look at a typical problem, subtracting whole numbers, and takeaway gets us in troubles, I think, but I'm on page 18. See if I can get this so it'll stay flat. Okay, an operation of arithmetic. And I need to say something more about this that relates to Emily's question. But we talk about takeaway and differences and unknown addend. Okay, so I need to translate. Here goes. Translations. You may remember me asking you a question like this last semester in 10. This is called the missing addend. Back to the document cam for just a moment, if you would please, Jonathan. The unknown addend, number 3. That's what we're really talking about here. So what is our answer here? Coming back to the board. You know it is 3. You're sophisticated, smug. But if you were 4 years old, you probably wouldn't be able to answer the question. Because you'd still be at that point where, like my grandkids, I give them a nickel and a dime to choose from, and they'll pick the nickel. I think it's great. I've been even known to put a penny and a dime out for them. Now, that's a little bit harder because they like the shininess of the dime, and I may regret it. But if they go for the biggest one, they'll take the penny, and I'm ahead 9 cents. And they're happy. Grandpa's been good. Okay? We know the answer here is the 3. Well, the way we talk about this problem as a subtraction, the takeaway is the way I suspect you learned it as a kid. And I told you not to do that. To do what? Come up from the bottom and ask, what can I add to the 4 to get 7? And I'm doing an addition problem, and we called that the Austrian method. We don't need to battle that battle again, I hope. Right? We're all comfortable with the Austrian method. You grimaced, Nancy. The Austrian method. And it's not talked about in your text, but it avoids the borrowing, and that was the whole point. So you go into some song and dance in this section on borrowing. And I don't know how it's going to affect the problems you do on the computer-based. But just as a reminder, if I have 4006, and I'm taking away a 2, a 3, a 5, and a 4, and I'm doing it with the Austrian method, there's no borrowing I have to do. Now, certainly, I don't have to borrow to take the 4 from the 6. But I say 2 plus 4 is 6. Then, no, trapped you. Slide over a little bit for me. Okay, because I didn't carry, right? But 2 and 4 is 6. If this had been, and say a 7, I would have put a 9 here and said 9 and 7 was 16 and carry the 1. No carry necessary this time. Now, what do I add to 5 to get the 0? A 5. 5 and 5 is 10. Carry making this a 4. 6 and 4 is 10. Carry, make this a 3. That's a 1, no borrowing. And that was the advantage of the Austrian method. What? I didn't follow you, Emily. Say that again, slower. Yes, I added 1 to the 3 to make 4. We got it? How soon? We lost it. Okay, we've got it now, right? Everybody's comfortable with that. Okay, back to the document cam. So there is our takeaway. I'm leaving takeaway alone. The important thing is that the answer is known as the difference. And part of our difficulty is to understand as we get expressions. You'll be told to find the difference of something. Find the sum. Find the product. You have to interpret the operation based on that. So when you look at the procedure for subtracting whole numbers, it says subtract the digits. Going to the document cam, please. Subtract the digits in the bottom number from the digits in the top number. And just use the Austrian method. Enough said. And you can see the borrowing nonsense that I try to avoid, this mess I refuse to ask you to do. That's what we're trying to avoid, the borrowing. Okay? And then, of course, you check, but if you're doing the Austrian method, what happens? You checked it. And it saves time. And life is good. Just keep telling yourself, you save time and life is good. Even if you don't want to agree. Now, section 3. Notice, I'm on page 27. I can't stand the graphic here. Let's go to the book. I'm sorry, they can do better. Anyway, at least making, I don't know, that's not even good comic work. Exponents. You know what an exponent is, right? Lots of work with exponents, so this isn't new. And, coming off there for a moment, this is what we talked about and spent lots and lots of time taking a number, as we go to the book now, a 20, and wrote it as a product of 4 and 5. That wouldn't be good enough for us last semester. We would have done what? Off there for a moment, Jonathan. Thank you. Prime factor it into 2 times 2 times 5. Too much vacation. Back to the problem. Okay, the factoring, that whole idea. Okay, enough of that. Then, the properties. They're all there. I'm not going to take time to show them on the screen. Come on off there for a moment, please. Okay, right buttons help. Now, at this point, watch the monitor. As we go ahead and we look at these properties on page 28 and 29, we've done all of them. Okay. Then the question, how do you multiply if you don't want to do the old-fashioned algorithm? Remember, we put one number up under the other number and we did long multiplication. My point is, look at what's done here to mess with your head. But it's the same way I'm going to mess with your head. Okay, back to the book here. 2 times 34 is 68. No problem, right? But then you need to realize that's the same as this problem. 2 times 30 plus 4, which is, as I can't slide over, as I try moving this just a little bit, there's my distributive property, correct? Okay. Now we're going to have to build on that, but what's being done there, let's come off there, is to help you understand why this works. That's just your old-fashioned kind of multiplication, right? I don't want to belabor it. I don't expect to spend a lot of time having you understand why, Jonathan, that doesn't need to be done. So you have an algorithm you use, and it works nicely, it works fast, and you don't expect to spend hours trying to understand why it worked. In the same way, I tell you, if I'm going to square 75, what's the shortcut?
Add 6, multiply, add 5.
Close, but no cigar. 75. Square the number. What's the shortcut?
Multiply
Not
6
go
times-
down, Natalie.
One digit.
Multiply 6 times 7, then add 25.
You go up 1.
Add 25.
So 7 times 8 is 56, and put the 25 after it. That was our shortcut for squaring a number ending in a 5, correct? Now, I'm not asking you to understand why that works, and by the way, we can answer that question very shortly with algebra. But for the moment, just to tell you that that process works and you can use it. So in the same way, when we look at an algorithm for multiplying, we just sort of accept it at the moment. So I'm not going to belabor that one at the bottom of page 29. And you are supposed to know how to do that at this point. So that's not new. Okay, what else can we do? As we come through there, at some point, we get to exponents. Okay, and this, again, not new. I love the fact that we're doing so much review. I'm on page 34. Here's my problem. 2 times 2 times 2 times 2 times 2 times 2 times 2. You just have to count the number of 2's. It's 7, so you write it as 2 to the 7th. The number of factors, and listen carefully, the number of factors is your exponent. So if I have the 2 written 7 times as a factor, that means I'm multiplying, then I'm going to write it as 2 to the 7th. So that's not new for you. And then, of course, you know this process of multiplying with powers of 10. This should be so simple for you as we go to it. It hardly merits any comment. And then, at the bottom of the page, remember the unit on large numbers in scientific notation? Thousands, millions, billions, trillions, quadrillions. What's after the quadrillion? Quintillion. Then? No. That's what's written down here. You know what a Google is and a Googleplex. In terms of notation, this is just the large number scientific notation unit coming off there. After the quadrillion, the quintillion. Somebody has 6 kids at once, 1 birth. Sextuplets. Sextuplets, so sectillion. Then septillion, octillion, nonillion, decillion. That's all from the preceding course. After decillion, you don't worry. No, an octillion was after the septillion, before the nonillion, which came before the decillion. You were back a few illions. Okay? So, in terms of what we've done, this is sort of trying to take an overview of where we've been and where we should be today. We have managed to cover, by Wednesday, the first 3 sections. So you should be in a position to do the work that has been assigned, and I'm going to come back to Isaac's question, since he didn't pick up on it the first time, where I would find the assignment by page number and problem number. I'll cover that in a moment, as long as the computer doesn't do whatever it does sometimes. And you have 3 sets of problems that I'll give you some extra time for the second section, Dion, so I will make the adjustment there. I know, but you need to enter your answers, right, to get credit for it. So I will go ahead so you can do that. What? I'm going to extend the time for you who does not want to use the computer, so what does it matter? I'm sorry, I couldn't pass that up. Okay, I need to come back to the laptop. I've got to give Isaac a bad time. Laptop, please. Now, this is the home page. I'm just going to zoom out here for a moment and get rid of, I clicked a button I shouldn't have. There we go. This is the home page. And what I wanted to do was come down here to the spring schedule. So I'm going to bring this down just a little bit, and I'm watching the time. Okay, and I bring this down here, went a little bit too far. There we go, spring 2009 schedule. Okay, and if I click on that, which I'm going to do, and hope, hey, it worked. Not always the case. Okay, and I'm going to swing down here, and what you will note, Isaac, week 1, just for you. And then I come to week 1, and then I scroll down. So click and scroll. Sounds like the title of a new club, the click and scroll. Okay, there is, no, not a dance. There is the homework assignment for section 1.1. And then we have section 1.2, which is, let's see, I'm trying to see which, I lost track. Page 23, is that what we're looking at? Yes. And then what we just did today, chapter 1.3, there's the homework. And if you're looking ahead, there's tomorrow's. So it references the text, and you could go ahead and do the problems, then get on the computer and spend some time doing it. I'm hoping that we are at the point where we can answer questions in 1.3 tomorrow and go into 1.4 and finish these 4 sections and be where I would like to be at the end of this week. So I always have to make sure I get done here so we finish at 11. I know that hasn't answered all your questions. And I do want to ask one more question before I close out here. I have 2 minutes. Larita, in terms of where are you going to be at the 2:30, 3:30 time frame? In the library. Yeah, that's optional. But 2:30 to 3:30, Larita's going to be available to answer questions. And in the library, you have the advantage of getting on the computer and doing things, right? So let's leave that today. 2:30 to 3:30, library. Larita will be there, willing to help. Get online if you have any questions. I'm hoping she can answer the questions I can't answer today. So with that, Jonathan, we started out with Rod Stewart. What's your close going to be?
I know I'm losing.
He said, I know I'm losing you, which is correctly a title from there. You're no more kind than was Debbie or Jennifer this morning. I hope I haven't lost you. And I look forward to seeing all of you in here tomorrow. And for those of you watching on Palomar, welcome to the broadcast, and we'll see you Monday through Friday.